This session is all about, the passwordless authentication using Passkeys and WebAuthn protocol. So how many of you know that, how Passkeys, how many of you use the Passkeys before? So hard about Passkeys? Okay. Okay. This only two. Okay, that's fine. See, we'll see how we can use Passkeys. So that it will won't get hacked actually. So if it is more complex, it's very difficult for humans to remember the passwords. Okay. So we have seen that, right? Whenever we use other sites, maybe each person could be having around tens of hundreds of websites they would have registered with. So remembering all these passwords for this each website is very difficult. So the common practice or the practice is they reuse the same password across all the sites. So this is a catch actually. The same password being used, or they try to do pattern-based passwords. Maybe they put some, their names or their kid names or their father names and do that. And one more problem is you forget the passwords. So maybe if you are keeping more complex passwords, it's very easy to forget. The human can't remember more than 3 complex passwords if you are using more than 12 characters. That is the research been done on that. So we try to do it, the forget password, or we try to reset the passwords. In order to do the reset passwords, right, we need the infra for it. Like, you need the SMS, you'll be sending it. You need the, they'll send the code to your email accounts. So what the tendency is, 50% of the people, right, if the password is not working, the tendency is they abandon that website. They don't want to log into that site. They move away from that. So this is hurting the a lot of companies, like mostly e-commerce ones and all the tech giants, right? Amazon, Apple, Gmail, these guys, mostly Amazon, it's a business is hurting actually. So mainly the problem is because of passwords and knowledge based, we're having issues with that. Next issue with passwords are phishing. So I think most of the people, right, they will be getting, some phishing emails, they're sending that your account is going to expire, please reset the password. While resetting the password, they give the link like this, this is, from Amazon. You can see that, the URL looks like Amazon.com, but, if you just, hover the mouse on it, it's going to somewhere else. That's the problem. See, even for software engineers, they can't recognize this, until unless they hover it. So think about the layman's. They are very. Any questions? Okay. So they click on it. What happens is, the same site, whatever the redirect link they're giving, it will be similar to the actual site. So what happens is, then user enter the username password there. So that, the bogus sites, right? They capture username password. They use the password for unauthorized, they use the password, whatever they want to do it with that. Left side, I have 3 links, right? 2 links, Microsoft.com, then the below one more link is that. See how difficult, for human to just, differentiate between these 2 links, right? See, anybody can see the difference? Who can see the difference, Microsoft.com and below the one more link is there. What is that? RNN. Just you have to just observe carefully, then only you'll come to know that. How many of us, if you are browsing site, how many of look us at the address bar? Most of the people we don't look at. Even we are software engineers, we don't look at the address bar, and we just, because the site is similar to other site, we just enter the username passwords. Okay. I've seen another example is bank.com. Below is a bank.com site. I think this one most of the people can't even figure it out, because even software engineers, I don't think so, because A is a different character I used there. So these are the two major problems we have in the passwords. So another problem we have is remote replay. So remote replay in the sense, right? See, the password database we can get in the dark web. Maybe they're cheap, very dead cheap. They'll sell for maybe $10, $20. You can get it. So who would have your username password, right? They can log into your account from other continents. Okay, they can do whatever they want. Now, I think, mostly the social networks, someone logins into your account, they will be sending alerts to you. Okay, that's how I think the other most usable sites, they're maintaining that. Other sites, they're not even, someone logs at your account, they don't even intimate you or send the alerts to you. That's a very big problem. Data breach. See, data breach in the sense, right? We store the passwords, right, at the server side, and maybe backend servers, we store it. So because we are storing the passwords in the database, they are target for hackers. They target, backend, because they have the username password is stored there. So once the data breach happens, if they are successfully able to just, get that details, they can sell that in dark web anywhere. So that is a data breach. Server side, we have to take more precautions while storing the passwords in the database sites. The reuse and sharing. See, as explained before, right, we will be having hundreds of sites we will register. We will be, most of the people, right, even software engineers, they are using the same password for all the sites. That's the problem. Suppose you have one rogue website, you register with it username password. Assume that, he able to get that password, he can able to log in into other sites. That's very dangerous, right? And we'll be sharing the passwords with the others. So Netflix password, how many would have shared, right? So they don't want you to share the passwords. Maybe suppose Netflix, you don't want to share it. So everyone want to buy their Netflix accounts. Okay, maybe that talk about. Yeah, then password management. So because we are storing the password at the server side now, as of now, the current trend. So we have to take a lot of measures. We have to hash it. We have to encrypt that. We have to take, a lot of measures. There will be auditing. There will be compliance issues. The government, we need to send the complaints, report the governments and all the security. We need to hire, auditing, a lot of other things. Then we have to build. If someone forgot the password, we have to build the reset or forget the password. So in order to do that, we need to have that, other mechanisms like, we need to send the email, the link, and SMS. So the problem is it cost is involved in that. So it costs, as per analysis, right? I think it's costing in a years for resetting the passwords. It's costing around $70 for doing the reset passwords. You can see that, how many times you do reset the passwords. I do maximum, I think, if I won't go to the particular website and I forgot the password and I had to reset the password and they had to go through a lot of, it will take a lot of time, but user experience is very, very bad. So you want to just get into LinkedIn or Twitter or whatever you want, but it takes 4, 5 minutes, 10 minutes, maybe based on the network latency and these things. Okay, so now you understand the password problems, right? You have any questions so far? So if you understand the problem, then the solution will be interesting. So these are the problems we have. Any questions you have so far? Okay. Then we'll go to next slide. So see the password problems, right? These are, this analysis, right? These surveys, Verizon, Verizon is doing, yearly there is a there is surveys, everyone is conducting. So in that, they found out that 81% of, the hacking related breaches, right, are using weak passwords or stolen passwords. Assume that 81%, what are the hacking things happen in the world, 81% related to the passwords. So if we remove the passwords, if we get rid of the passwords, we will be able to solve 81% of the problems, hacking problems in our life. Okay. Then there is /net survey. So from Q4 2022, the phishing emails, right? There is 1,265% increases in the phishing emails since Q4 2002. That is Corona time. Okay. And the credential phishing, like they want to just take your credentials. So that this they want to just take credential. There is a credential phishing mails. They will send it. So if you have similar sites, you will be entering your username password there. They take that credentials. So there is an increase, right? 967% increase since Q4 2022. Now we are in the era of AI, right? With that AI, and there is sophistication, sending the phishing emails. There is a 54% of sophistication being increased compared to last 16 days. They're talking about Fidelians. See that with using this all the latest technologies, they can send you the phishing mails or SMS or calls. They can do it. They can take your passwords. They used unauthorized way of then you will be getting the call from police stations or whatever the way you'll be getting the calls. So it's a very dangerous passwords if you're not able to remember properly, and if you're not using strong passwords. Okay, so these are the problems with the passwords. Okay, so now we need to get rid of the passwords. We have to go passwordless now. So what are now there are some techniques available for doing passwordless authentication. We have biometrics. So with your biometrics, like you have fingerprint scanners, you have face IDs, touch IDs. Mostly the maybe it's going to come maybe DNA in future, and you can do authenticate. The problem is you are giving your biometrics to them, so it's not safe. So magic links. If you want to log into one site, what they do is they can send one link to your email, so that you go to the email and click on that link, you'll just get into it to access that particular website. That's also inconvenience because you have to go to another Gmail or wherever another email website now to get that link. And OTPs. OTPs are right. This also involve costs. SMS. SMS they'll send it. They have software. Tokens available, but mostly SMS will get it. It's also not convenient because its cost is involved. Suppose if you don't have the network, you won't be getting that. Sometimes you have seen that it will take 30 seconds, 40 seconds to get that OTPs. And there are push notifications. Google is doing that. If you want to log in it, they will send you this push notification. You do that authentication in other devices so that you can access the site. That was a passwordless. As of now, it's happening. We'll see. Now we have another technique. It's called Passkeys. Okay. Before I get into this one, I have any questions so far? I'll just clear it out and I'll go forward. This is an interesting topic coming up. Any questions so far? Okay. The passkeys, we have seen that passkeys and passwords. There is similar. There's pass and common is there, right? So we get rid of the password. Is there are the three kind of credentials we have. What we know means we have knowledge base. What we know is passwords we remember, and what we have. It's kind of I show you that I have the security key here. What I can do is I have this security key. There I can store my the keys like cryptographic keys here. And there is another is what you are, kind of what you are in the sense you have fingerprints, you have face, you have DNA, you have there's so many other biological authentication coming up. Okay, So these are the three types we have. So passkeys, maybe, yeah, I'll just get to the passkeys now. So passkeys are basically cryptography key, the public key, cryptography keys. We'll talk about that. What is a public key cryptography is now. Okay. So these are the asymmetric, cryptography algorithms we have. So asymmetric public key cryptography, how it works is, I just generated the public key and private key now here. There is OpenSSL is a one library we have. We can use that to generate the public key and private key. There is RSA algorithm. That is a symmetric algorithm. Using that, we can generate the public key and private key. We have other algorithms, elliptic curves. This is the most recent and secure one. So most of the people will be knowing RSA. So I just taking the example of RSA. So we can use this OpenSSL libraries to generate the public key and private key. So this is the public key. You have right. Public key is below blue color, and private key is, you have that begin RSA private key. So that is a private key and public key. This is how it looks like. See what we do with this public keys and private keys. Okay. So yep. So first command, right? What we're trying to do is we're trying to create the private key, RSA. So when you use the private key, when you generate the private key, it basically works on prime numbers, the prime numbers and factorization. The RSA algorithm works. So the private key have this, they generate the two primary numbers with a long around 16, 17 digits for prime numbers each two. If you are using 2048 bits, from that private key, I can generate the public key. That is second command is that. From that private key, you can see that in is keypad.pem. So what we can do with the private keys, private key and public keys, right? So if you heard about the HTTPS, right, it's already using this concepts, public key and private key, asymmetric algorithm they use. So let me explain that. We have two keys now, public key and private key. Normally, the private key will be keep with the guy who generate that. That is private to it. That's very, very secret that you have to keep with you the private key. The public key, you can give it to someone or your friends, or you can distribute to the whole world if you want. So whatever you create, you encrypt with public key, the only person in the world who can decrypt that message is the private key. Okay, that's how the algorithms been created, so that nobody can crack it if you are using good number of bits key generation. And previously we used 2048 bits. It's very difficult to crack, but it's not impossible. But there is other new algorithms there in the market, elliptic curves. We can use that. So you're clear on this part. So with public key, we can encrypt the data. Suppose you have hi message, hi there, you can encrypt that with the public key. The only person in the world who can decrypt is the private key. Nobody else can do that decryption. Okay. If you do encrypt, technically speaking, right, I have the key, I do encrypt with public key and decrypt with private key. Okay. Then there is a call. We can do the reverse way also. We can do it. The private key, we can do encryption. With public key, we can decrypt it if you are using RSA. Okay. If you are using elliptic curves, we can verify. Okay. Technically, the private key do encrypt. The public key, we can decrypt or verify that. This we call digital signature. Okay. The only person in the world, right, who can do your signature is the only you. You have the private key. That's theoretically the names came like this. Technically, this is kind of doing encryption. You have the key, do encryption with private key or public key. If you do with public key, it is called encryption. If you do with private key, it is called signature. The digital signature is, that's how it works. You have it all in the world. You heard about this PDF digital signatures or digital signatures, right? What they do is basically this. They have the private key. They just encrypt with their private key some content. So with public key, whoever is having that key, public key, maybe you can give it to your friend, or you can give it to whole classroom, or you can give it to the whole world. Whoever is having the public key, they can do decryption of that particular encrypted message from private key, or they can do verification. They decrypt or verify based on the algorithms. Okay. So basically we can verify that digital signature is done by the person who is having private key or not. If you're able to verify it is, if it is able to decrypt or verify, you're sure that that's been encrypted by private key. Okay. So this is the idea, right? This been used, in passkeys. But this idea been used, when you do SSH, right, with other machines. If you want to passwordless log into other machines, you have two machines, mission A and mission B. You want to do SSH to mission B, you used to add. We have that. Many people would have done that. A public key they'll add to the mission B, and you can do simulation without passwords. You can just do SSH to other machines. Okay, this is the key idea behind the passkeys. Okay. Yeah. Any questions? This is very, very important. If you're not able to understand this, you can't understand anything further. Any questions so far? Oh, HTTPS, you want to explain? It will take some, I don't know, I have time now, no? 255. Up to what time you have? 315, right? Okay. That is a different story. This is public infrastructure comes into picture. The CL, certificate authority, comes into picture. They get a certificate for you. They have private key and public key. When you get this browser, get the certificate, right? That is a public key. Now, the private key will communicate. Okay, so I don't have time. Okay, I will maybe if you want more detail, I'll explain later. Okay, this is the key concepts. Okay, let's get into the demo. Just quickly want to demo on this one. I don't have much time, I think. Okay, how Passkeys works, right? Let me go to github.com. Okay, I have the GitHub accounts. So I have already logged in. Just let me logged out from GitHub. So I want to sign in now. See, if you click on this one, see, these are the discoverable passkeys. So I have already created the passkeys here. So in my mission, I have the passkey. What I can do is here, I just, I'm using the iCloud keychain. What I have to do is I have to authenticate now, because I want to, if you want, I used, Touch ID for, log into my mission. I'm just using my Touch ID. See, it got logged into GitHub. So you don't need to enter the username. You don't enter the password. You not remember the password now. Your device is remember the password for you. That's how simple it is. So that, it took, very, very less time for logging to this website. So user experience is very, very good. And, you don't need to reset the passwords. It saves some money for them, who's created this website. Okay. How to register with that? The new passkey. What you can do is, what are those? Settings. Okay. So you have password authentication here. You have add passkey. I have two passkeys been added. I have to one with my laptop, one with add passkey. So where you want to generate the passkey? I have options here. I want to do it to Google. I have password manager. This is iCloud keychain password manager. This is a mobile. So I can tab it. What I'm doing now is I'm using my security key. I tapped is pin protect by pin. Just enter the pin. Next it. Tapped it. I just tapped it. Passkey nickname. Security. I just need to remember that, right? To where they added, security key. So now I have 3 passkeys. This passkey is available on my key, the security key, hardware key. These two are one with Google, one with Apple. I have this passkey. This is how easy it is to get the passkeys and use it. Okay, let's get into. See, we have now public key and private key concept I explained you. We need some devices to generate that public key and private key. So we call that as authenticators. So we have two kind of authenticators. What authenticators will do is they create for you the public key and private key. They store that public key and private key, or they store the private key securely in that device. Okay. So we have two kind of authenticators: the platform authenticators and roaming authenticators. Okay. The platform authenticators are like I have in my laptop, tab, or mobile. I can use create that public key and private key and store that in my laptop. That's we call platform authenticators. Like if you can remember, like Windows platform, Linux platforms, the macOS platforms, like that. So the roaming authenticators are this one. This is the hardware key where you can use different environments, like you can use in Windows, you can use in Mac OS, you can use somewhere. So you just need to plug into your machine and you can use this passkeys. This is the hardware related. So you can roaming means you can use anywhere, in other machines as well, you can use it. Okay, so now we have the device who can create the passkeys for you and it can store. So you want to access from this side, we need some APIs to access from these keys. Okay, so there is a FIDO Alliance, Fast Identity Online. There is Alliance. All top tech giants, right? They join together, including all top, Apple, Google, Amazon, Microsoft. They formed the alliance. This is a FIDO Alliance. They came up with the standards. Now to access your passkeys, in the devices, there is two protocols: Web Authentication Protocol, Client to Authenticator Protocol. So Web Authentication Protocol tells about from the web browser how we can access the platform authenticators. The Client to Authenticator Protocol, it tells you how to access passkeys from your device, from browser to this device. How can I access this device from your browser? There's a they can do is they can use maybe USB, or they can do Bluetooth, NFC. These techniques can use to communicate with this device. Okay. So this is the flow. Basically, relaying party is the server, client is the browser, the authenticator we have here. So when you want to log into the one particular website, what you do is from the browser, we send the request to relaying party saying that I want to use the passkeys, want to authenticate with your site, right? So what it does is it will send the challenge, one random byte they will send to the browser. Browser, what it will do is it will send to the authenticator. What authenticator will do is it will create the private key and public key for you and sign that challenge and send back to the browser. The public key will send back to the browser. Authenticator will still have the private key. It won't get sent to anyone. So only authenticator will have that. It will safely store the private key because it represents your identity. Okay, it's been protected, right? If you want, you can use fingerprints to protect that, or any pin you can use. In this case, I use the pin to protect this private key in this one. So this is how it works. See, relaying party in the server, it calls the client side JS. They have the APIs to communicate with authenticator. There is a WebAuthn API we have. So when WebAuthn API calls, it pop-up came so that where we can select where we want to store your passkeys, like maybe your browser, or maybe in the laptop or in the hardware keys, right? So if you want to store in this one, right, there is a protocol called Client to Authenticator Protocol can use to store communicate with this device. or if you have a laptop, there is a WebAuthn protocol. Okay, let's skip this one and how much time we have. So there are passkeys. There are two types of passkeys. Okay, we have sync passkeys and device bound. The sync passkeys are, suppose now I logged into, I used my laptop, Apple ID. So what happens is when I create the passkeys, it gets synced with the cloud, the Apple cloud will get synced. Wherever you use that Apple ID in other devices, suppose I use in my mobile or some other iPad, it will get synced to that device. You don't need to create separate passkeys there. Okay, that is called sync passkeys. There is a device bound passkeys. So if you are created now the private key using this device, it won't leave anywhere. It is more secure. So nobody can, unless even they take this device, it's been protected by the pin. Okay, so it is the most secured actually. So if you want to have a cross device, right? If you want to use, I'm using currently this machine, and if you want to use another Windows machine, I can carry this and do this authentication with this. Suppose there's the inconvenience is that I have to carry always this if you have hardware keys, right? The software keys you don't need to carry. It gets synced, if you are using same account. If you are an Android platform, if you are using Chrome, you have this, the Google password manager. It will store the private key for you, and that bin will get backed up in Google Cloud with encryption. Okay, so this is the registration flow I just talked about. The first users, they want to use passkeys. What they do is they say that I want to register with the passkeys. So the request will get sent to the server. Server will send the random bytes for you. So you give that random bytes to authenticator. So authenticator, what it does is it will give the pop-up, this, a site you want to access and create the passkeys, where you want to create that, whether you want to use Google or password manager or iOS password or any security keys. So once you select that option, maybe you have to authenticate it. So how you log into your machine, maybe you can use a password or touch ID or face ID, maybe in iOS, you can use face IDs. Or if you are using this kind of security keys, you can use the PIN. Once you authenticate, then the public key and private key will get created, and public key will get sent to the server. So this is the registration flow. The next time they want to do authentication, so the server is having already the public key. Remember that. So if you want to authenticate, what happens is now user says, I want to log in with the passkeys. There is a button, or maybe you have a discoverable passkeys. So when you click on the button, a request goes to the server. Server will send the challenge, same. Now we have this API, JavaScript API, navigator.credential.get API will use. So it will goes to the authenticator. Which authenticator you want to use? Maybe user has to select it. After selection, right, what happens is it has to give maybe what is the authentication you're using for your machine or your security device. Once you do that, that particular private key will get selected for that username. Then it will get signed with private key. That private key signed message will get sent to server. So now using the public server has already public key. So it will decrypt that, it will verify that. So it came from authenticator resource. So who's having private key? They sign the message. The corresponding public key only can do decryption or verification. So that now the server knows that whenever the registration time, the private key being used, same private key used for signing, so that only is able to decrypt it. So that is digital identity being verified. That's how it works actually. Have any questions? Okay, I think browser, it comes with browser have and yeah. No. No, it's asking for password, right?
No, this passkey, how is it different from
Mm-hmm.
when I give username password? Google pops up, can I store it? And then automatically, when I give a touch ID,
Mm-hmm.
automatically it fills username and password.
That is autofill feature we have in browser.
Autofill.
And in the password manager, as of now, it's Google Password Manager storing username password for you. It will fill for you. So the problem with that is they are storing, that is anyway, that is a password. Suppose you want to use, you don't want to use that Google. Suppose you are having bank transactions. You don't want to Google to remember that. So you'll use this kind of security. There is an option in the passkeys where you want to store exactly. So that's how there's more security. If you want least security, you can go with password managers. If you want more security, you buy one key, you store your private key here. You buy two, normally buy two, create backup for you. That's how our house keys works at same way. Any questions so far? See, the security is always complex. Okay, it's very difficult for you to understand. But yeah, any questions?
Yeah, one question here.
That's what you have another key. You keep keys. You have house. You have you lost the key. What you'll do? Same. That's the this is the most secure. Nobody can crack this. They were tried already. Nobody can crack it. Yeah.
Yeah, I'm connecting to GitHub through my command line. So how I do? I create a private key locally, keep it I create a public key and keep it in
The command
GitHub
line
server.
APIs,
How it works?
it's not actually as of now WebAuthn API only for web. The user consent is required now. That is the overall idea of that. See that you are doing with a mission to mission communication. Let's keep it aside now. That's a different, and they have still they can use this is anyway the key, public key and private key. If you can use same mechanism there also, but this WebAuthn protocol specially designed because the users are dumb enough to forget the passwords. So they want to store that private key securely. So it represents your identity. Suppose you are losing that identity means just gone. So somebody can take that and log in with your account. So suppose most of the banks now, right? Even Wells Fargo, we are the board member of the FIDO Alliance, where we sit with the Google and all the members. We are trying to do that, financial transaction with this passkeys. That's where in the next few years you'll see that most of the financial institutions will be using these passkeys. It's the most sophisticated way, right? So you don't need to enter username, password. It's all discoverable within a few seconds. You will able to, not even seconds, milliseconds, you can able to log into any site. I'll show you that. What are statistics we have from that. So any other questions you have? That's what I explained now. You get one more key with you, spare key. So you passkey, one passkey here, you just need to do the same step. If you put two passkeys, it'll ask you where you want to store the passkey. So one passkey here, one passkey in another device. You keep it in locker, one passkey. If you lose it, you use that. That's how. Yeah, if it is this been stolen, okay, assume it's been protected by a pin. I have the pin. Or the passkeys comes with fingerprint scanners. They're costly. This costed me around 6,500 rupees. If you want to go with fingerprint scanners, it's cost around 12K or something that. So this is by default, it is you have two-factor authentication is coming up in this one. This is one you have, that is one factor. What it's another factor. By default is multi-factor authentication is coming with passkeys. No key expiration. It won't expire the key. We don't have concept called key expiration. Private key always stay. It's not like, will expire. It will stay forever. This is most secured of, doing things in authentication. It won't expire. Suppose you want to remove that, passkey support, right? What you can do is, I can go and delete from here. Suppose you thought, okay, my passkey been stolen or somebody taken it, they can log into my account. So what you can do is simply go here and delete it. That's all, nothing.
I have a question.
Yeah.
So like you suggest, I bought 2 keys.
Hmm.
Okay, so one key I have many passkeys such as 50.
Hmm.
Okay, so can I copy that
No,
entire thing to another?
no. That's the reason. Just we have, when you are doing passkey registration, you have to do that registration again with another passkey. So if you're able to copy, right? See, this is the most secured key in the world. If you are able to copy it, means you have to extract from this. If you are able to extract, means somebody can do also extraction. This is the most, sophisticated crypto process are there in this key. So they won't allow you to take it out the private keys. Just whatever you send them, they just do encryption and send the text back. They won't allow you to take the private key from these keys. Password manager still they store the password, right? Passkeys. Yeah. See, that's where, right? If you use password managers for storing your passkey, they sync with the private cloud. See, suppose you have the bank account. You want to store your password in password managers. All right. So that's the reason we have this sophisticated way of doing things. Okay. Yeah, I'm done actually. So any questions, So okay, last slide I have, I'll show you. With this one, right, what happening is the statistics I'll show you. This you surprised with statistics, right? See, 75% of sign-in time being reduction happened when you use the passkeys. So I just showed the GitHub. It just one click, I selected it with my finger scanner, just able to log in within few milliseconds. If you are using a typing a password, most of the time forget the password, resetting that, most of cost involved in that. Sign-in success rate is 4x been improved. Success rate. Normally you forget the passwords, you reset, go and you abandon the sites. So 4x is increment in the password, like sign-in success rates. 50% reduction in abandonment, right? Normally if you are logging to one site, you forget the password, you just leave that site. You don't get into that. So there is 50% reduction in that. 95% password reset reduction happened. So see the organization, how much cost they're saving. See, they have to send the email, they have to maintain that infra, they want to send the SMS, they want to maintain the infra for it. So there is 95% reduction in the passwords resets. So assume how much they're saving, all the big gains. Okay. Okay. If you don't have any other question, you have any other questions? Hmm. Hmm. See, initially start with the passwords, then you give support for passkeys. See, industry is not yet ready for passkeys. See, even how many of you know, not when I asked you passkeys, only 2, 3, you are software engineers, we are developers. We know that we are engineers building software for the whole world. We don't know what is passkey as of now. See how layman can understand the passkey. It's very difficult. If you want to currently build it, you build with password first, then you give that passkey support. That's how all the tech giants are doing now. Slowly, I think down the line, 5 to 10 years, you don't see the passwords, only passkeys will be seeing it. Okay. Okay, thank you for time, guys.